Welcome to tonight's video on Unit 10, Part 1. We're going to review a little bit of how we found limits and then come up with a new definition of the limits called the epsilon delta definition. First, a review of limits. Remember a couple things, what we talked about limits earlier this year. Number one, when finding the limit as x approaches a number, the preferred method that we went is to plug in the number. However, sometimes that can make it indeterminate. So then once you determine that it's indeterminate, you must do some algebra or try something else to find the limit. Observing highest powers only works for rational functions. And remember that you must always simplify piecewise functions before evaluating the limits. So let's look at some examples here. First, this one's pretty straightforward. It's a polynomial, so we can substitute in. So we get 5 times negative 2 minus 3 times negative 2 squared plus 1. So it's going to equal negative 10 minus 12 plus 1, which is negative 21. The limit as x approaches 5 pi over 6 of sine x, well, we can find the sine of 5 pi over 6, which is 1/2. Same thing with limit of cosine of x approaches 4 pi over 3. It is cosine 4 pi over 3, which is in the third quadrant, so it would be negative 1/2. Number 4, when we substitute in, we get the square root of 4 plus 5, and then minus 3 outside, over 4 minus 4, which means, notice the square root of 9 minus 3 over 0. Well, 3 minus 3, so this is indeterminate. Right, so now we have to do some algebra, and remember when there's a radical, we can rationalize either the numerator or the denominator. In this case, we will rationalize the numerator and make it the square root of x plus 5 minus 3 times the square root of x plus 5 plus 3, and do the same thing to the denominator. So we get the limit as x approaches 4 of, when we FOIL here, we get x plus 5 minus 9 over x minus 4 times rad x plus 5 plus 3. Remember the denominator here, you're just going to leave because you'll be able to cancel eventually, because if you notice, this becomes x approaches 4 of x minus 4 over so notice the x minus 4's cancel out, and you're left with the limit as x approaches 4 of 1 over the square root of x plus 5 plus 3. And now you can find that limit by substituting in. So it's going to give you 1/6 as your limit. Number 5, this one is a piecewise function because it's absolute value, right? So remember, absolute value of x minus 2 minus 3 is equal to, oh sorry, it's x plus 2 minus 3. It's equal to x plus 2 if x is greater than or equal to negative 2. Right, we're just doing the absolute value part first, then we'll subtract 3. And then it's negative x minus 2 if x is less than negative 2. But then you have to subtract 3, So really, it's x minus 1 if x is greater than or equal to negative 2, and negative x minus 5 if x is less than negative 2. So now, remember, to find the limit as it approaches negative 2, we have to find the limit from the left. And in this case, the limit from the left would be negative x minus 5. So it'd be the opposite of negative 2 minus 5. So it'd be 2 minus 5, which is negative 3. The limit as x approaches negative 2 from the right is x minus 1. So that would be negative 2 minus 1, which is also negative 3, which means the limit as x approaches, as x approaches negative 2 in general of the absolute value of x plus 2 minus 3 of all this stuff is equal to negative 3. Final answer. All right. So here's some more examples. This one's a rational function. So notice a rational function, we can observe the highest powers when it's going to infinity. So notice the highest power is x squared, so that means it's going to be 4 over 5. So now, for